Hey guys, how's it going? So today we're going to be covering a topic in differential equations that seems daunting at first, but is actually quite simple as long as you follow this formula. And that's the equation that has the shape of m plus m n y prime is equal to 0. Now, generally, a few key factors of this. In order for this to be solvable, the equation has to be exact. And for it to be exact, m sub y has to equal n sub x. So let me give you an example. So let's say you have 3x plus 5 plus 3y minus 3y prime, y prime is equal to 0. This is very clearly exact because my equals nx which is equal to 0. Now, generally, I said m plus n y prime. You might also see it in the form of m dx plus n dy equals 0. Don't worry about it. They both mean the exact same thing. If you divide both sides by dx, you end up with something here, right? So yeah, just a warning. If you see both of these, they're perfectly fine. Yeah, so it has to be exact for there to be a solution. If it's not exact, it's not going to work. Let me give you an example. What example can I find? Let's say 6x cubed, for example, 6x cubed plus 2 y 2xy, let's say y prime is equal to 0. Okay, so let's see, then 6x cubed. Okay, so my, this is 0. Nx would be 2, nx would be 2y. Yeah, this is very clearly not exact. And why does it have to be exact for this to work? Well, let's base it off this example. Let's prove this by contradiction. Let's pretend that it wasn't exact, but we still tried to carry on with the rest of the equation. Okay, so then you would do cactus. I don't know the form for this, so I'm going to call it cactus. Cactus sub x, xy, let's call it 6x cubed. It is 6x cubed anyways. 6x cubed. And then cactus of xy. I try to sound like a professional, but I'm really garbage, guys. That would equal, okay, so then that would be 2x, 1.5 x4, sorry, 1.5 x4 plus a function, let's call it g of y, plus g of y. Okay, but let's try to like differentiate this with respect to y. cactus sub y will now equal, let's say y, will now equal, this sub y will now equal g prime y, yeah. Which is also equal to 2xy. Yeah, this doesn't make any sense because look here, it's 2xy and then g prime y. It should not have any x component in here. If your equation's not exact, you're going to end up with this being impossible to solve. So it's not doable. Now back here, this equation we said was exact. So let's base off from here. Let me do this marker and eraser here. Yeah, draw. So then you would have cactus sub x. That's a pretty dry looking cactus. It's been in the Sahara Desert for a really long time. Cactus sub x of xy is equal to 3x plus 5. Okay, so cactus of xy will equal 1.5x squared plus 5x plus g of y. Okay, now cactus sub y of xy is equal to yeah, so the x's all cancel out when you're differentiating with respect to y. You're left with this equals g prime y. And like g prime y is clearly equal to 3y minus 3. Which means that cactus of xy is equal to 1.5x squared plus 5x so yeah, g of y I jumped a step, but like g prime y was 3y minus 3, so g of y will be 1.5y squared from this minus 3y. And this is equal to c. So when we solve these types of exact equations where m plus n y prime is equal to 0, you're going to end up usually with cactus of xy equals something which is equal to c. You leave it in an implicit form. Don't try to separate it out unless it's really easy to. You should not be required to do this on your test. Yeah. Let's do one more example. Let's do one more example of this. Okay, so this time, this was an exercise that I got on one of my homework assignments. Y e to the power of 7xy plus x dx plus bx e to the power of 7xy dy is equal to 0. Okay, the goal is find the value of b that makes this equation exact, and then find the implicit function solution for this equation. So how do we do this? First of all, you should recognize this is a very good question. We need to label this m. Y to the e is this is m, and then this stuff is n, right? Okay, so let's just write that down here to be even more explicit. I don't really like to skip steps. Y e to the power of 7xy plus x. Yeah, that's m. So yeah, to be exact, my and m sub y has to equal m n sub x. M for monster sub y has to be equal to n for Naruto sub x. Yeah, so m sub y, let's do this. That's e to the power of 7xy plus, okay, now let's differentiate this. 7y e to the power of xy. Yeah, 7, yeah, sorry. 7xy, yeah. 7xy e to the power of 7x. Am I right? Give me a second to see if that's right. So when you yeah, so e to the power of 7xy, and then times e to the 7xy. Yeah, that's right. That's right. Okay, so yeah, now check n. N is equal to bx e to the power of 7xy. N sub x is equal to, let's see, n sub x is equal to be to 7xy plus but actually I have a better idea of doing this. Let's factor out b. You'll see why in a second. It equals b times, okay, so I'm just saying b times, okay, and then let's differentiate this part. That's e to the power of 7xy plus, okay, let's see, x times 7, no, x times e to the power of 7xy times 7y. Okay, and that is equal to b e to the power of 7xy plus 7xy e to the power of 7xy. All right, and it's pretty obvious from here, this is exactly equal. B has to equal 1. Which means that your n has to equal x e 7xy. All right, now this equation is exact. And we use out our old algorithm to solve this. First, assume cactus sub x. You could, it doesn't matter. You could have done this cactus sub y and then set it equal to n and then work backwards to find cactus sub x. but like I just like to use a conventional way. I like to stick to one pattern. So let's just do this. Cactus sub x, xy is equal to y e to the power of 7xy plus x. Okay, that means that when you try to anti-differentiate it, so cactus of xy is equal to, well, let's see here. I get 1 over 7e, now let me make sure. Yeah, so 1y times, I'm going to assume, I'm going to treat here y like a constant. Y times 1 over 7y e to the power of 7xy plus 1/2 x squared. And that is equal to 1 over 7 e to the power of 7xy plus 1/2 x squared. And needs to include the h of y or g of y or whatever. Okay, so I should have included the h of y here as well. Okay, now let's differentiate this cactus with respect to y. So cactus sub y, xy, is equal to this. I'm gonna highlight this so we can come back to it. Okay, so that is equal to x e to the power of 7xy plus h prime y Okay, so let's compare this. Where was your n? N was x e to the power of, oh wait, hang on. Did I mess something up? No, I didn't mess anything. Sorry, I was looking at here and then I thought this was n, but no, my n was here. So yeah, so n is equal to x e 7xy then here. So it's pretty obvious that h prime y is equal to 0. And this also equals h of y. You could say h of y equals c, but since like your final solution already equals c, you can just say h of y is 0. Yeah. So now plug this back in here, and you're left with cactus of xy is equal to 1 over 7 e to the power of 7xy plus 1/2 x squared and this is equal to c. And that's the answer. So I hope you guys liked today's video. I'll be making more soon. I'd love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.